Today in geometry we're going to begin a discussion of special right triangles. Now I will tell you this is a section that people have particular issue with. And part of it has to do with their understanding of right triangles. Part of it has to do with can they apply it to what they already know. So let's take a look at some examples so I can give you a hint of how this is going to work. In this picture that we're going to look at today, to be able to deal with a 45-45-90 triangle, really what they want us to be able to do is, given the length of one side, they want us to really be able to find the others. So really the experience that you should know is if it's 45-45-90, if two angles are the same, that also means that two sides are the same. So these are both s long, and the hypotenuse happens to be s square root of 2. So on a problem like this down here, kind of have a couple ways that we can solve this. Again, it doesn't mean it's the only way, but there are a couple ways to solve this. First of all, if it's 45-45-90, the two sides that make up the 90-degree angle have to be the same. So if this one happens to be 9, that means that this side over here will also be 9. It also means that this h side is going to be 9 square root of 2. So that's kind of two ways to deal with how to, go through and fill in the sides if you know them. Now, on this one it's a little bit more difficult because this side is 2 square root of 2. This is a 45 and a 45 degree and 90 angle. This is going to be 2 square root of 2 long as well. Now to find this side where x is, I take a side and multiply it by the square root of 2. So if this is the side, and I multiply it by the square root of 2, if I were to take these two square roots and put them together, square root of 2 times the square root of 2 would be the square root of 4, which happens to be 2. Which means this entire side would be equal to 4. Now again, it's a little more difficult when you're talking about using the information, of the sides, and the hypotenuse is whatever the sides are times the square root of 2. Now, I actually think the 45-45-90 is easier than the 30-60-90. So let's take a look at that one. To do this, the two sides, they kind of have a shorter side and a longer side. The way that you figure it out is 30, 60, and 90 are the three angles. So this side right here across from the 30, this side is going to be considered the shorter side, because it's across from the smaller angle. This right here, the 60, s square root of 3 is going to be over there. That's going to be considered the longer side. And the hypotenuse is kind of easy to find. So let's take a look at what one of these examples would look like. And I actually want to go through and I want to add some stuff onto this. So first of all, the degrees are not in there, so let's add these. This is 60 and this is 30. Now that should be on your original picture. For some reason it wasn't. So I'm going to go through and try to figure this out. So if I look up here, the big key to all of these is the letter S. If I know S, I can figure out all of them. And S has to be across from the 30. So that's the D over here. That's not going to help me too much. This side with the 5 is across from the 60. So 60 is going to be s square root of 5. So really that means this side equals s square root of 3. So if I want to go through and figure out what this side is equal to, I'm going to actually have to take 5 and set it equal to s square root of 3 to solve this. Now this is where people have a hard time, because if you're not very good with your multiplying and dividing stuff and knowing how to treat square roots, this is going to be an issue here. So first of all, if I were to multiply both sides by the square root of 3, normally I would write 5 square root of 3. I'd write the square root of 3 second. On this one, square root of 3 times the square root of 3 would be the square root of 9, which is 3. So 3s. So to find s, I would divide both sides by 3. So s would be 5 square root of 3 over 3. Now we said that s was the same as this side d. So really this is d equals 5 square root of 3 over 3. Now this side is going to be 2s because it's a hypotenuse. So I know that D and S are the same thing. So to find F, I would have to do 2 times 5 square root of 3 over 3. Really the only things that you can put together on this are the 2 and the 5. So F is going to be 10 square root of 3 over 3. Now listen, this is going to be a section that really requires practice. And it's also going to require that you're really paying attention to how to solve these and how to put your numbers together. So we're going to go through actually several examples of these, but I'm going to encourage you to make sure you pull out your post-it notes. They have the 30, 60, 90 and the 45, 45, 90 on it because that will probably help the most. Okay, let's take a look at another example. Now this is a 45, 45, 90. So you can tell these are both the same. In our picture, these would be the ones that would be S. And this side has to be S square root of 2. So on this one, I know S is equal to 5 square root of 6. So to find S square root of 2, I would have to take this and multiply it by the square root of 2. Now the big thing for us is if I were to really take this and put these together, 6 is really 2 times 3. So there's already a 2 here, so 2 2s and a 3. And this is going to be that perfect square that we were talking about before. So square root of 4 is 2. So 5 times 2 would be 10. So H is going to be 10 square root of 3. Okay, let's try another. Now on this one, they tell us that this is a 45, 45, 90, and they want us to find this side that's x. So we have a couple different ways that we can go about this. First of all, if this is x, this side is too. And it might almost be easier to do Pythagorean theorem, because x squared and x squared together is going to have to give you 22 squared. So 22 squared is 484. And these two together would be 2x squared. So divide by 2. It's going to be 242. So to find x, I would have to do the square root of that. Now remember again, we talked about finding perfect squares. So I happen to know that this is going to be 2 times 121. 121 is a perfect square of 11. So it's going to be 11 square root of 2. Okay, let's see. I might skip ahead a little bit. I want to do a 30, 60, 90 one so we can deal with that. Here's a 30, 60, 90. And we have all of our sides labeled. Now, what may help you on something like this is to actually take your triangle and redraw it. So if this is 30 and this is 60, with that general triangle that we had, across from the 30 was S, the hypotenuse was 2s, and this is s square root of 3. So it might at least help you to be able to figure out what sides you know. And we can kind of tell by looking at this that those two are going to match. So that means that I know that 18 has to equal s square root of 3. Now we're going to do something like we did before. Multiply both sides by the square root of 3. So this will be 18 square root of 3. And this square root of 3 times square root of 3 is the square root of 9, which is 3. I'm going to divide by 3. Now when I divide these, only these two numbers out in front can divide, if they can. So 18 divided by 3 is 6. So it'll be 6 square root of 3. So that's what s equals. And in this picture, notice our S and D match up. which means on this one that D is going to have to be 6 square root of 3. Now to find F, if we were to look at this picture, 2S and F match up. So F has to equal 2 times what S was. So 2 times 6 square root of 3, which means that it's going to be 12 square root of 3. So F equals 12 square root of 3. Now again, remember, this is going to be one of those sections where you're really going to have to practice. So please make sure if you're having any questions or concerns to let me know.